Okay, another exam question that we're going to try to answer for 8 marks. So the line L1 has a vector equation r is equal to, respectively, and the line L2 has vector equation r is equal to, where lambda and mu are parameters. The lines L1 and L2 intersect at the point A, and the acute angle between L1 and L2 is theta. A, find the coordinates of A, and B, find the value of cos theta, giving your answer as a simplified fraction. Well, again, like in our previous vector question that was answered, we're going to deal with r is equal to A plus lambda B. And we're going to do the same thing. So let's do the math. So we've got 5 minus lambda times minus 1. So here 5, we have 5 plus lambda times minus 1 is minus lambda. So we've got 5 minus lambda, and we'll deal with that first. And then of course we have 2 plus lambda, 2 plus lambda times 1. So that's just 2 plus lambda. And finally, 1 plus lambda times 2, which is 1 plus 2 lambda. So we've got 1 plus 2 lambda. And that's the first of our working out done. And then, of course, if the lines actually do intersect, they're all equal to 0. But we'll put this on the right-hand side, L2. So we work out our L2 vector now. So we've got 4 plus mu times 1. Well, here's the 4. Let's just, there we go, get rid of that. Here's the 4 plus mu times 1. So it's 4 plus mu. So 4 plus mu. And then 1 plus mu times 0 is just 1. And 1 plus mu times minus 1 is 1 minus mu. So we've got 1 minus mu. And now we're all set to go. So we can equate now our vectors. So this is part A, of course, we're answering. Let's just scroll down. And, well, same thing like last time in the last video with vectors. I'm going to keep lambda and mu on the left-hand side. So I've got minus lambda minus mu is equal to 4 minus 5, which is minus 1. Yeah, which is equal to minus 1. And in fact, I'll leave there because I think, let's be consistent, I didn't put the equal sign in until the last thing. So here we go. We've got lambda just alone by itself. There's no mu on this side. Is equal to 1 minus 2, which is again minus 1, which is minus 1. And then I've got 2 lambda plus mu here on this side. So I've got 2 lambda plus mu, bringing minus u from right-hand side to left-hand side, is equal to 0. Is equal to 0. So here we go. And is equal to, and now I can find the value of lambda and mu. So let's extend the page. And, well, let's solve again simultaneously. Solving simultaneously. Solving simultaneously again. And I'll write it out. Minus lambda, I and j components, minus lambda minus mu is equal to minus 1. And I call that 1. Call that equation 1. Equation 1, and I've just got lambda, there's no mu here, is equal to minus 1 as well, and that's my equation 2. Well, that's nice. I can just add 1 plus 2. So 1 plus 2, and that gives us, well, lambda is eliminated. Yeah. If I add, lambdas are gone, and I've got minus mu is equal to minus 1 plus minus 1 is minus 2. So mu is equal to 2. And if mu is equal to 2, I substitute mu is equal to 2. Whoops, doesn't look like a 2. Careful. Mu is equal to 2 in equation 1. In equation, equation 2. Sorry, there's no mu in equation 2, in equation 1. So there we have it. And I will have minus lambda, of course, minus 2, yeah, because mu is equal to 2, is equal to minus 1. So that gives me lambda, minus lambda, is equal to 2 minus 1, which is 1, and that tells me that lambda is equal to minus 1. Therefore, lambda is equal to minus 1. Oh, now, we can check the k components, but you'll find that there is some consistency. So I will just now substitute this value of lambda is equal to minus 1 into the line L1. And L1 is, let's go back to the question, L1 is 5, 2, and 1. So 5, 2, and 1, minus 1, 1, and 2. Because lambda is equal to minus 1. So I've got, remember, R is equal to A plus lambda B. So let's extend the page. And we've got 5, 2, and 1. So 5, 2, and 1. And we've got minus 1 times, well, we've got to go back. So that, yeah, that minus 1, 1, and 2. So we've got to subtract this. Yep, minus 1, 1, and 2. And that gives us what? 5 minus minus 1, that gives us 6. 2 minus 1, that gives us 1. And 1 minus 2, that gives us minus 1. So here we have it after substituting the value of lambda is equal to minus 1. So now if extend the page, let's just scroll down. And that's the answer, by the way, to part A. Whoops, this is not working. Apologies for this. It's all real time. And remember, part A, find the coordinates of A. Well, your coordinates of A is 6, x equals 6. X equals 6, x, y, and z. But I, j, and k. I is equal to 6, j is equal to 1, and k is equal to minus 1. Part B, we have to find the value of cos theta giving your answer as a simplified fraction. So let's have a look at part B. Part B. So we're going to let A equal, what was it, minus 1, 1, and 2. Let's just check that. A was minus 1, yep, the scalar quantity of the line L1, minus 1, 1, and 2. That was assigned to lambda as a scalar quantity, so we've got to write minus 1, 1, and 2. And for B will equal, and if we go back again, it was mu times 1, 0, and minus 1. So that's what we're going to use, 1, 0, and minus 1. 1, 0, and minus 1. And now, of course, because we are going to use a dot b over the modulus of a, so let's write it out, times the modulus of b. So using a dot b over the modulus of a times the modulus of b, we need to find our dot product. So a dot b is minus 1, 1 and 2, and multiplied by 1, 0 and minus 1. And oops, put the dot back here, and that gives us, of course, minus 1 minus 2, so we have to do the sum of it, so that gives us minus 1 1, so that gives us minus 1, 0 and minus 2, and all of that, if we add it up, that gives us minus 3. So the sum is equal to negative 3, minus 3. Now we want the modulus of a. The modulus of a will give us well, minus 1 all squared. So using the theorem, minus 1 all squared plus 1 squared plus 2 squared, and that gives us the root of 6. I can write it along here. That gives us the root of 6, and the modulus of b, I'm concerned about time here, but hopefully you can bear with me. Just showing you the procedural steps. The modulus of b is 1 squared plus 0 squared and plus minus 1 all squared. Plus minus 1 all squared. And that gives us the root of 2. So, therefore, using a dot b over the modulus of a times the modulus of b, which is equal to cos theta, cos theta will be equal to the minus 3 over, because that's the dot product, a dot b, over the root of 6 times the root of 2. The root of 6 times the root of 2, which is equal to 3 over root 12. Is the same as 3 over root, yeah, and I've forgotten the modulus sign, yeah, because the modulus of all of that, 3 over the root of 12. And the root of 12, of course, is 4 times 3, so that's equal to 3 over 2 root 3. We've got to rationalize the denominator, of course, so therefore that will give you 3 over 2 root 3, and we've got to multiply by 2 root 3 over 2 root 3, and that will end up with, that will give you 6 root 3 over and 2 root 3 times root 3, that will give you root 3 times the root of 3, of course, is 3, so that will give you over 2 times 3, which is 6. So we end up with 2 root 3 times 2 root 3, which is 4 root 3, which is 12. Apologies for the slowness there. 4 times 3, which gives you 4 times 3, which is 12. So you end up with 6 root 3 over 12. And of course 6 cancels with the 12. Goes into it twice. And you end up with the answer of root 3 over 2. And that's it for 8 marks.